Welcome back, everybody. We're going to finish up chapter 6 by looking at, let's do orange this time. Excuse me. Excuse me. So chapter 6, section 6.3. And this time we are going to look at confidence intervals. For a population proportion. Back in section 6.1, I talked about P hat, and again that is P hat, being the unbiased estimator for P, where P hat is the sample proportion and P is the population proportion. Going back to probability in and of itself, P hat will equal the number of successes out of the total number of outcomes for the sample. And if we look at the confidence interval formula, being the point estimate plus or minus the critical value times the standard deviation of the point estimate. So I keep going back to that same generic formula. What that would look like for proportions is P hat plus or minus. These will always be Z critical values. And then the standard deviation for P hat is P hat times Q hat over N. So you might be asking what Q hat is. Q hat is 1 minus P hat. It is the probability of failure. So whatever your P hat is for your sample, you just subtract that from 1 and that gives you your Q hat. Now there's something that has to be true to be able to use the Z distribution to determine a proportion confidence interval. In other words, when we talked about the sampling distribution of X bar and what allowed us to use the Z distribution when the standard deviation was known for a confidence interval, or the T distribution for this confidence interval when the standard deviation wasn't known, what allowed that to happen is our N being greater than or equal to 30. That goes back to the central limit theorem, or the original population being known to be normally distributed. Those allowed us to use the Z and the T. Well, what allows us to use the Z distribution, which is what we have to use to be able to find the Z critical value, is that N times P hat has got to be greater than or equal to 10, and N times Q hat has got to be greater than or equal to 10. So you need to check these before completing the problem. Or your estimate may be invalid. So we're going to look at an example. And we'll say 75, or in a recent survey, "75 out of the 124 people surveyed said they use some type of streaming network on a regular basis." Calculate a 99% confidence interval for the true proportion of people who use the streaming network regularly. So this is how I know that it is a proportion problem. For one thing, I don't have a mean and standard deviation. The other thing, it says find the confidence interval for the proportion. So my formula is p hat plus or minus z sub c times the square root of p hat q hat over n. But before I do that, I want to check n times p hat and n times q hat and make sure they're greater than or equal to 10. So that would be 124 times 75 out of 124, which is going to be 75. And then 124 times 49 out of 124, which is 49. And both of those are greater than or equal to 10, so I'm good to go. So that checks and that checks. So I'm now going to put in, if I do 75 divided by 124, you can either put this in as a decimal or you can leave it as a fraction. If you put it in as a decimal, it has to be rounded. So I'm going to leave it as a fraction. So 75 out of 124 plus or minus my z-score for this problem, because it's 99%. If you'll remember back to what we did in section 6.1, that's 2.576 times the square root of 75 over 124 times 49 over 124 all over 124. Now, just like before, you can do this on your calculator. So if I go to, excuse me, it's not second. If I go to stat and go over to tests. I'm going to scroll down until you see 1 prop z interval. X is going to be the number of successes, so in this case it's 75. N is 124. My confidence level is 0.99. And calculate. And that gives me my confidence interval. And you also see the p-hat there. So the confidence interval is from 0.492 to 0.718. So to interpret this, I would say I am 99% confident the true proportion of people who use a streaming network regularly is between 0.492 and 0.718. So between 49.2% and 71.8% of people use streaming networks regularly. And we normally do the proportion in decimals, but if you were talking in terms of what this means realistically, someone might understand it in percentages a lot easier than they do in proportions. Just to reiterate, I went to Stat, I went over to Tests, and I scrolled down until I found 1 prop z interval. X is the number of successes. N is the sample size. If given the proportion or percentage in a problem, and the sample size, p hat equals x over n. So x will equal n times p hat. To put this in the calculator, you must use a whole number for x. So round according to rounding rules. So in other words, if you have to multiply n times p hat to get what x is, and it comes out to be a decimal, round it according to rounding rules to get a whole number. So the next video that I will put up will include all of the parts of the Module 1 document, the Module 3 document for Chapter 6. Have a great day.